Hi guys, we're gonna go over chapter 6, which is the normal probability distribution. It's kind of like the normal curve and the binomial curve all together in one. And so I kind of made section 6.1 and 6.2 together just because they go together really well. And so some things that you had to remember from the normal distribution. The normal distribution is that normal curve, if you remember. So it looks like this. Okay, remember it's bell-shaped. So bell-shaped curve. And if you guys remembered, what went at the bottom was what goes in the middle was your mean. And then to find your values were your standard deviations, and you would add and subtract them. So like this was 1 standard deviation, 2 standard deviations, 3 standard deviations, and then 1 below, 2 below, and 3 below. Okay, so in general, if I don't give you values and if it's a normal distribution, your mean or your mu is 0. Okay, and then your standard deviation, which is your sigma, is 1. And that's like going to be the case in a normal distribution curve. Okay, now a density curve. A density curve is a graph of any continuous probability, so it has to be continuous. The total area under the curve. So it doesn't always have to be a curve. It could be a rectangle or a triangle, but the total area under the curve is exactly 1. Okay, because the total area under any density curve is equal to 1. Therefore, the correspondence between height and area go together. So if you remember here, you had the percentages in between each part. So you had like 34, I'm not gonna write them all out, but you had 13.5%. If you add them all up, remember what percent you get? You get 100%. If you add them all up, you get 100%, which if I convert that to a decimal, that's 1. And that's essentially a density curve. So this right here is actually an example of a density curve. It's just a specific one we look at. So I'm gonna write a little formula. I'll write it again, but the area of any curve or I'm gonna put a rectangle, is width times height. And we're gonna use this idea for the first example. So example 1 says to the right is a density curve for a distribution of values between 0 and 1. It's called a uniform distribution because they all have the same height. Use geometry to determine the answers to these questions. And so again, feel free to try these questions. If you want to pause it and try it out, you can, or if you just want to watch it, you can. So it says, what percent of data lies above 0.7? So we're going to use this 0.7 as like our x-axis. So if you look at it, it goes between 0 and 1. Now the number I forgot to give you is I forgot to give you this number. So this should be 1. I usually give it to you. It could be 2 sometimes, it could be 3, but it's 1 for now. And so the percentage of that lies above 0.7. So here, between 0 and 1 is 0.5. So 0.7 is over here somewhere. It's not exactly there, but we're close enough. 0.7 is there. So what percentage lies above 0.7? So what we're trying to do is we're trying to figure out what percentage is this. Okay, so the way I would write this is the formula is width times height. So your width is this distance. So how far apart is 0.7 and 1? It's 0.3. And then I'm going to multiply it by my height. And how tall is it? It's 1. And what's 1 times 0.3? It's 0.3. So it says what percentage? So what's 0.3 in a percentage? If I convert that, it's 30%. Okay. Try now what percentage lies below 0.4. So 0.4 is over here. And so we're trying to figure out what percentage lies below it. So again, it's width times height. So my width between 0 and 0.4 is 0.4. And my height is 1, so that's 0.4. And if I want to convert that to a percentage, that's 40%. Okay, what percentage lies in between 0.3 and 0.9? Well, it's another, so 0.3 is right here and 0.9 is over here. So we want to figure out this shaded region. I know the picture kind of messes up trying to use 3 different colors. But here's my question. How far apart is 0.3 and 0.9? That's 0.6 apart. So it's 0.6 and my height is still 1. If I multiply it together, it's I get 0.6, which is 60%. Okay, and then it says what percentage values lies exactly at 0.8. So 0.8, I know, right? 0.8 is right here somewhere. And it's not above or below, it's like a line, like right here. So if it's a line, and this is 0.8, the probability is, well, my width is actually 0 because it's a value. It's not a shaded left or right. And then my height is 1. Well, 0 times 1 is 0. You can make a little note. A line has no area. Think about it. If I ask you the area of a line, you can't find that. You have to find it of a shaded region. Okay, so a little, again, standard normal distribution area is height times width, or width times height, either or. So in a standard normal distribution curve, again, okay, we have our percentages at the bottom. And so these right here is your mean, and then this is 1 standard deviation. This is 2 standard deviations. I'm just gonna write 2 and then 3. And this is -1, -2, and -3. So if you remember this part, this right here are called your standard deviations or your z-scores. And then this is your mean. So the standard normal distribution is a normal distribution with parameters of a mean of 0 and a standard deviation of 1. The total area under the curve is equal to 1, or 100%. Okay, what is the 98, 95, and 99.7% rule? When does it apply? So this right here, if you remember, this is called the empirical rule. And it applies only when the z-scores are exact numbers, like standard deviations. Okay, that's the only time this works. Okay, so go ahead and we're gonna go on to the next page and we're gonna try an example all the way through. Okay, so according to the CDC, the heights of 12-year-old males are approximately normal distributed with a mean of 149. I'm gonna underline normally distributed and a standard deviation of 8. Sketch this distribution, labeling the mean and the points 1, 2, and 3 standard deviations from the mean. Okay, so we're gonna go ahead and I'm gonna draw this out really, not like the whole thing because I do have some notes to add in, but I'm gonna go ahead and draw a normal distributed curve. And then I'm gonna go ahead and write out the values at the bottom, and I'm actually gonna include the percentages too. So the mean is 149, so if you remember that goes in the middle. I should have left more space, so 149, and the standard deviation is 8. So remember, you add and subtract 8 every time to find those values. So I got 157, 165, and 173, and then on the left you subtract 8, so you get 141, 133, and 125. And I should have left more space. And then to find the percentages, it's just using the empirical rule, remember? So it's 34%, 34%, 13.5, 13.5, 2.35, I should have made it better, 2.35, and then 0.15, and then 0.15. And if you add them all up, you get 100%. So that was the first part. Now again, I left some space because we're gonna do some problems, and if you wanna make a little note here, you can. So it says, using the earlier example on the previous page on the guided notes, this one, I had it on the previous page. What is the percentage of 12-year-old boys that will be over 158 centimeters tall? Okay, so what I'm gonna do is I'm actually gonna write out the steps out, and then we're gonna solve it, and then I'm gonna write again a little bit of notes to show you what to do. A little note though is round to 3 decimals. Okay, it's always gonna be 3, sometimes it's 4, sometimes if it's standard, if it's in scientific notation, you have to do more than 3. But let's go ahead and solve this. So the first step you want to do is you want to sketch. Now when I say sketch, it's like literally the smallest sketch ever. So we're looking at 12-year-old boys above 158. So I'm going to draw a small curve. Now if you look at 158, 158 is not right here. 157 is. Okay, so before what you could have done is all you had to do was, if it was over 157, is add the percentages and you're done. 158 is not on this. And so essentially what we're going to be using is we're going to be using the normal curve, but our calculators to solve this. So what I'm going to do is I'm going to go ahead and mark 158. Now I know it's to the right of my mean because 149 would be the middle. So 158 is to the right. And since it says over, am I shading to the left or to the right? Shading to the right. So step 1 is to sketch. Okay. Step 2 is to write out what you are solving. Okay, so in this case, again, you don't have to write out the steps like every single time. I'm just showing you guys what you would do. So in this case, we're going to write out what we're solving. So we're trying to find the probability or the percentage of our x values that are greater than 158. And that's it. It's always greater than, it's always less than. It actually includes 158. But again, we're going to be using our calculators to solve that. And then our third step is to use calculator. Okay, so I'm going to write out the calculator work on the top. That's why I left the space. So it says use calculator. So what we're going to be using is we're going to be using normal CDF. And if you remember, before we're using PDF for binomial, but what C does is the shade to... it depends, but it's the shading to the left or right. Depends on the situation. So it's the shading part. So before we were finding exact values, now we're finding less than, greater than, over, under, between, and so that's when we use CDF. If I'm just finding exact values, you don't have to use C, you can use P. Okay, now how you get there, it's going to be second, and then you hit vars. And then it's the second one, which says normal CDF. And you're going to be using a lot of these buttons, so you're going to be really familiar with all of them. Okay. So we're going to go ahead and I'm going to write this out. And then, so it says use calculator. So we're going to I'm going to write it out first. So normal CDF. And then I'm going to show you guys ahead on the calculator what to type in. So if I want 158 and over, the first number is going to be your lower, and when you get to your calculator, you'll see that. So my lower number is 158. Okay, now I want every number above 158, and it doesn't tell you where to stop. And so I always use 1,000 and then a negative 1,000 if I'm trying to find under. So I'm going to write 1,000. Some books use 10,000, some people use 1,000,000. I feel like 1,000's good. Unless the numbers are really, really big, then I would use something bigger, but I always use 1,000. The third number is always your mean, and so I gave you your mean to be 149. And your last number is always your standard deviation, which is 8. Okay, and then just like before in binomials, I do make you label which number is what. So this is going to be your lower, this is your upper, this is your mean, and this is your standard deviation. And so we're going to go ahead and use our calculators to solve this. So the first thing I'm going to do is I'm going to turn it on. Then I'm going to hit second, which is the blue button. And then I go to vars, which is next to the clear button. And then I'm going to go down to 2. So I have an example in already. But my lower was 158, so I'm going to write 158. My upper is 1,000. My mean is 149. And my standard deviation is 8. Okay, and I'm just going to write that number down. So remember 3 decimal places, 0.130. I'm going to write 4 just because it's ends in a 0. Okay, and that is my answer, and I'm done. So it says, what percentage? Well, this is a decimal. I'm okay with the decimal, but if you had to convert this to a percentage, this would be 13.03%. I'm okay leaving them in decimals, actually. I prefer decimals, but if it asks for a percentage, you can convert it or you don't. I always have students tend to mess up the conversion, so I was like, just write out what the calculator says. It says what percentage of, so let's go on to 3. What percentage of 12-year-old boys will be between 131 and 140? So again, we're going to follow the same steps. I'm not going to write out the steps again, but I'm just going to do them. And you're going to get familiar with writing, like doing this out. I always do a picture, and yes, I do require a picture because it helps you kind of figure out like what percentage things should be. So 131, if you look at this, 131 is to the left of the mean. And 140 is also to the left of the mean. So it's going to be in this area. So this is 131 and 140. And I'm going to shade this. Okay, so that's the first part. Second step is write out the problem. So the probability of, we're trying to find the numbers between. So I always do 131 is less than x, which is less than 140. Okay, it's always going to be less than and greater than. It's never going to be equal to. Okay, and then our third step is to use our calculator. So we're going to write, again, normal CDF. And this time, my lower, since I want to find a number in between, is going to be 131. My upper is 140, because we're finding the numbers in between. My mean is 149, and my standard deviation is 8. And I'm going to label this lower, upper, mean, and standard deviation. So I'm going to go ahead and use my calculator once again and see what I get. So if I go again, second, vars, number 2, I'm going to change this to 131. I'm going to change this to 140. The nice thing is my mean stayed and my standard deviation stayed. And I hit enter. I get 11 or 0.11, 0.118. And that's it. All right, now this next question is actually a really cool question. It says, suppose that the distribution of test scores is approximately normal, and the middle 95% of test scores are between 72 and 84. What are the mean and standard deviation of this distribution? Okay, so I'm going to draw a picture out. And now if you remember your percentages, 95 is the 2 standard deviations above and below. So I'm going to draw a small picture. Okay. So what essentially we're trying to do is we're trying to figure out what this is. Trying to figure out mu. And I'm given 95%. So I'm given 72 and 84. Now if you pause it and try to think about how to find the middle number, you're going to be able to. Okay, so think about it as this. I'm trying to find the halfway point between 72 and 84. Okay, I know 95% of the data lies here. That's how I'm just getting these problems. But I want to try to find the middle point. So if you think about it, how do you find the middle? Well, it's kind of like the median. Okay, so to find the mean, what you're going to do is you're going to add 72 and 84, and you're going to divide it by 2. You're trying to find the average of the two numbers. And if you actually use your calculator, you're going to get 78. So this number is 78. Now it's kind of like a puzzle. If you're given this number, 78 now, you're trying to figure out, okay, your standard deviation, which is how much in between is each value. Now, before you do that, it's easier to find these numbers first to solve it. So what number comes in between 72 and 78 halfway? Okay, well, if I add them up and divide by 2, I get 75. And then same thing, I'm going to add 78 and 84 and divide by 2. I'm going to get 81. Okay, so remember, standard deviation is how much you're adding and subtracting to get every number. So if I'm starting at 78 and going to 81, how much am I adding? I'm adding 3. And then every single time I do that, if you look at it, you're adding 3 every time. And same thing for this way, you're subtracting 3 and you're subtracting 3. So what's my standard deviation? My standard deviation is 3. And my work is like on my graph. I don't really have much work for it. Can you calculate the percentage of scores that are above 80? Explain. Well, now I can, yes. Yes, because we found mu and sigma. Okay, so if I were to actually solve this, I'm going to go I'm just going to do the normal CDF part. We're going to do a normal CDF. We're doing above 80, so we're going to be 80 to 1,000. Our mean is 78, and our standard deviation is 3. and I would just use my calculator and calculate that. Okay. Now, sometimes you're given your z-score and you're asked to solve a probability. So the nice thing about z-scores is it is the distance on the horizontal axis. Of a normal distribution curve. Okay. The area is the shaded region under the curve. Okay. Sometimes it's a percent, sometimes it's a decimal. I prefer decimals, but sometimes your answer would be a percentage. Okay. And so we're going to go ahead and we're going to try an example that deals with normal distribution. But before I do that, I have one more set of notes. Okay, it says, how do you do a normal distribution on a calculator? What do you need to know for the exam? And then what is the normal distribution or standard normal distribution? Okay, so for this one, a normal calculator, what you have to do is the first thing you want to do, the 3 steps are you have to sketch, write out problem, and label calculator. That's essentially the steps I want you to do. Okay, so for this one right here, you're going to use normal CDF. Now, we're going to do problems that are backwards. So this is going from point to percentage. Okay, we're essentially going to be doing this backwards, and so when we do it backwards, it's actually going to be, the first step is going to be the same. It's going to be sketch, and then the next one is actually going to be, you're going to use the calculator. And the third step is you're going to write a sentence. Yes, and I will kind of give you an idea of what that looks like. So this is when you're going from percentage to point. So this one's point to percentage, which is what we did on the front, and then we go from percentage to point. What is the standard normal distribution? It's still using normal CDF, but this time we use mean to be 0 and sigma to be 1. Okay, so this is if it's a standard normal distribution. So the third example says, find the proportion of observations from the standard normal distribution that are less, and then it does all these. So here's the keywords, standard normal distribution. So notice in this problem, I don't give you your mean and I don't give you your standard deviation. But your mean is 0 and your standard deviation is 1. So we're going to go ahead and try solving these problems. So this time we're trying to find the proportion. Now remember, proportion is the same as a percentage or a decimal or a fraction. That's what proportion means. We talked about that like the first day of class. And so we're going to go ahead and follow the steps of the top. So the first one says sketch. Again, very simple sketch. And so your sketch is going to be less than 0.54. Now if this is your z-score, okay, this is your z-score, we're going to go ahead and this is above the standard above 0, so we're going to go on this side and write 0.54, and we're going on the left. Okay, the next part says write out problem. So this is where it's a little different. It's not x anymore. It's, since this is a z-score, we're going to write z is less than 0.54. I was going to write 1.54. Okay, so essentially it's the same problem as the front, except this time I don't give you an x value, I give you your z-score, and that's what all of these are. These are all z-scores. And then same thing before, less than or greater than, no equal to's. Okay, and then my third step is to write out on my calculator what I'm doing. So normal CDF, and we want everything less than 0.54. So our lower this time, if you look at it, our lower is going to be negative 1,000. Our upper is 0.54, and then since I don't give you your mean, it's 0, and your standard deviation is 1. And yes, again, I make you label this part because we're going to eventually get to something else with these numbers. Okay, so we're going to go ahead and use my calculator, and we're going to go ahead and solve this. So second, vars, same steps. Okay, so our lower is negative 1,000. And here's a little thing you can't use minus. Minus is not the same as negative. Negative is next to the decimal, so you're going to do negative 1,000. My mean is, or my upper is 0.54. My mean is 0, and my standard deviation is 1. And when I hit enter, again, I get 0.705, and I don't have to convert to a just decimal. This is perfect. Or a percentage, that's fine. Okay, so it says greater than negative 1.12, so we're going to try the next one again. So we're going to go ahead and draw a curve. Negative 1.12, so remember the mark in the middle is 0, because that's your mean. So negative 1.12 is on the left. But I want everything greater than, so when I shade, I'm actually shading to the right. All right, so it's going to be probability of z is greater than negative 1.12. Okay, so we're going to go ahead and write normal CDF. Okay, my lower is negative 1.12. My upper is 1,000. My mean is 0, and my standard deviation is 1. And I'm going to label this lower, upper, mean, and sigma. I'm going to use my calculator once again. So I'm going to go second, vars, number 2. I'm going to do negative 1.12. Upper is 1,000, 0, and 1. I'm going to get 80.869. And that's it. Okay, so I'm gonna have you guys try these two values out. I'm just gonna write out the answers. So try it out, and then if you do have questions on Monday, you can ask me. Greater than 3.89. So this one's going to be, actually, I don't know if I flipped it. I'm gonna try it out real quick. Is going to be 5.01 times 10 to the negative 5. So see if you're getting those numbers. And then this one is going to be 0.278. Okay, so try those out, see if you got them. Again, I do want the sketch. I want you to write the problem out and then use the calculator. Okay, and then this last one I'll go over. It says within 1.5 standard deviations of the mean. So 1.5 standard deviations above the mean, or of the mean. It doesn't say below or above. So this is going to be negative 1.5, and this is going to be 1.5. And we're trying to figure out what this value is. Okay, so that's my picture. And so we're going to write the probability of negative 1.5 is less than z, which is greater than 1.5. And that's essentially 1.5 standard deviations of the mean. If it was asking 2, then it'd be negative 2 to 2. If it was asking a half, then it'd be negative a half to a positive a half. And then you would do the same thing. Normal CDF. My lower is negative 1.5. My upper is 1.5. My mean is 0, and my standard deviation is 1. So this is going to be my lower, my upper, my mean, and my standard deviation. I'm going to use my calculator. So I'm typing in negative 1.5 to 1.5 and then 0 and 1. I got 0.86. I was going to convert that to a percentage. And that's it. Okay, so let's go ahead and try out example 4 and example 5. And then, yeah, we'll go on. So a distribution of test scores is approximately normal, and Joe scores in the 85th percentile. How many standard deviations above the mean did he score? Okay, so this time, if you notice, I give you a percent, and I wanna have you figure out how many standard deviations above the mean did he score. I'm actually asking you find your z-score. So this is completely different. This is not starting from a point and going to percent. This is starting from a percent and going to a point, or your z-score. Okay, so we're gonna go ahead and we're gonna use this part of my thing. So the first thing we're gonna do is sketch. So 85th percentile. Now, remember the middle is 50th percentile, so 85th is over here somewhere. Okay, so what that means is 85% is on the left part of that graph. Remember we were talking about percentile and how much better you're doing? So 85th percentile is on the left. So essentially what we want to do is we want to figure out what this value is. Now notice it is approximately normal, and we're looking at the standard deviations. All right, so to do this one, we're not going to use normal CDF. We're actually going to do something called inverse norm. Okay, so to get to inverse norm, you're going to do second vars. And instead of number 2, we're actually going to do number 3, which is called inverse norm. Okay, so it's the inverse of a normal curve is what that stands for. And so if we go there, now yours might be a little different. So second vars, and instead of 2, we're going to go to 3. Okay, it asks you for area. Now this area is always going to be to the left. So if you look at your picture, your to the left area is 0.85. So I'm going to do 0.85, and then asks you for your mean and standard deviation, which in this case is 0 and 1. Now you might not have this tail part. Don't worry about the tail part. It automatically goes to the left if you don't have this part. So I'm going to keep it to the left the entire time. So I'm going to write 0.85. Now you can't write 85. You have to write it as a decimal. So 85th percentile is 85%, or 0.85, and then 0 and 1. And I'm going to label it. This is area, this is mean, and this is standard deviation. And I get 1.036. Okay, and so that right there is a z-score. Now, how much above did he do? How many standard deviations above the mean did he score? So that's essentially the third step. So the calculator work was step 2, and the third step is write a sentence. So I'm going to write he scored 1.036 standard deviations above the mean. And that's it. Okay, so in a normal distribution, Q1 is how many standard deviations below the mean. Okay, so we know it's a normal distribution again. Q1 is the first quartile, if you remember back from the third chapter. So Q1 is that 25% mark. So how many standard deviations below the mean that is. So again, we're going to go ahead and create a sketch. And 25% is over here somewhere. So this right here, now 25% in a decimal is 0.25. So that's what essentially we have. This time we're trying to figure out what your z-score is. So again, try it out if you want, but this is the sketch. The next thing is we're going to do inverse norm. And it's always area to the left, so we're going to write 0.25. And since it's a normal distribution and it didn't give you your mean or standard deviation, it's 0 and 1. Okay, so again, we have to label this. So this is area, this is mean, and this is standard deviation. And yes, I do that because I do like seeing like some work. Like I don't want you to just write the answers out. And so we're going to use our calculator once again. So we're going to do second vars, number 3, 0.25, 0 and 1, keep it on the left. And then I get negative 0.674. And what's my third step? My third step is to write a sentence. So I'm going to say Q1 is 0.674. Notice I didn't write the negative because I'm going to write standard deviations below the mean. So that word below automatically means the negative part. Okay. Our last page is all examples of what we just covered. So if you want to try pausing this and trying them out, you can, or if you want to try them all out, you can. But we're going to go ahead and go through, I'm going to go through a couple of them, and then I'm going to just give you the answers to some of them. And then, yeah, so we'll go from there. So it says in example 6, in 2008 Wimbledon tennis tournament, Rafael Nadal averaged 115 miles per hour on his first serves. Assume that the distribution of his first serve speeds is normal with a mean of 115 and a standard deviation of 6. Now this 115 and this 115 mean the same thing. So I'm going to write some things down, right? Mu is 115 and sigma is 6. Okay, so it says, about what proportion of his first serves would you expect to be slower than 103 miles per hour. So again, the first thing I'm gonna do is I'm gonna draw a sketch. Now his mean is 115 and I'm asking 103. So 103 is smaller than 115. So I'm gonna go over here and I'm gonna write 103. And then I'm asking slower then. So is slower to the left or to the right? It's to the left. Okay, so essentially that's my sketch. We're trying to figure out that percentage. The second step is to write out the probability. So probability of, and now since this time I'm giving you a mean and standard deviation, we're gonna use the variable x. And it's slower than, so it's gonna be less than 103. And then our third step is going to be write out the calculator work. So normal, CDF, and then since we're looking for lower, it's gonna be negative 1,000 to 103. And then my mean is 115 and my standard deviation is 6. Okay, so this time we don't have to use 0 and 1. I give you the mean and I give you the standard deviation. And we're gonna go ahead and use our calculator. So second vars, number 2. Lower is negative 1,000. Our upper is 103. Our mean is 115 and our standard deviation is 6. And so I get 0.023. Okay. For B and C, I'm again just going to go ahead and give you the answers. I'm not gonna actually go over the work. If you, again, have questions, just let me know, but it's more just practice problems. So this is going to be 0.202. And for this one, you're going to do 0.9196. So again, see if you can get those answers. It's more just practice, and I'm trying to include more practice problems. It says the fastest 38% of first serves go in at least at what speed? So this time I'm asking what is this x value we're looking at, and I give you the percentage. And so essentially this is the second method. So we're gonna go ahead and create a picture. Now fast is 30%. Now halfway is the 50% mark, so 30% is over here. So essentially I give you this number, it's 0.3 or 30%. We're actually asked to find what is your mean, or what is this value here? What's your x value? Okay, so the way we're gonna do this is we're gonna do inverse norm. Now here's the trick. Inverse norm, this number is always to the left. And if the whole curve, and it's always gonna be true, the whole curve is 100% or 1. If this is 0.3, what is this number? Well, all I do is subtract 1 minus 0.3, and I get 0.7. And that's what we're gonna plug in here. So again, a little thing is the first number is always the area to the left. So if this is 0.3 to the right, because it's the fastest 30%, the slowest would be 70%. And your mean is going to be 115, and your standard deviation, we're looking for, mean is 115, and your standard deviation is 6. And again, so that's going to be area, mean, and standard deviation. So again, to get to that point, you hit second vars. Number 3, area is 0.7, mean is 115, and sigma is 6. And then I just hit enter, and I automatically get 118.146. And then if you're using inverse norm, remember you do have to write a sentence. So I'm gonna just write a simple sentence saying the fastest 30% of serves goes at least 118.146 mph. Something really simple where you're actually putting the question into it. And that's it. Okay, our last question. It says a different player has a standard deviation of 8 miles per hour on his first serve, and 20% of his serves go at less than 100 miles per hour. If the distribution of his serve speeds is approximately normal, what is his average first speed? So this time I'm asking, what is his mean? Okay, so this one's a little tricky actually. So we're gonna go ahead and draw it out real quick. So it says 20% of his serves go less than 100 miles per hour. So I'm gonna go ahead and shade in this part right here. This is 20% or 0.2. All right, and it goes 100 miles per hour. So we're given this value right here. We're trying to find his average. We're trying to figure out what this is. Now, notice I give you the standard deviation, but I don't give you the mean. So this one, again, we're gonna go ahead and try to find our z-score. And I'll explain why in a bit. So we're gonna go ahead and do inverse norm. And the area to the left, now the nice thing is it's 20% to the left, so that's gonna be 0.2. Now, I don't give you the mean. That's what we're actually asked to find. I give you the standard deviation, but you can only use the mean and standard deviation together. So we're gonna go ahead and use 0 and 1. So if I don't give you some of this information, we're gonna automatically go back to the original like z-score. So this right here is going to be your area, your mean, and your standard deviation. So again, we're not using the 8 because the 8 only goes with the mean, which we're asked to find. Now we're gonna go to this number and I'm gonna go ahead and plug it into my calculator. I'm gonna get negative 0.842. Okay, and what is this number called? Well, this number is called your z-score. But I'm not asked to find the z-score. I'm asked to find his average. Okay, so essentially what we're gonna do is we're gonna use the z-score formula to find his average. So if you remember your z-score formula, which was z equals x minus your mean over your standard deviation, I give you almost every single bit of information except your mu, and that's what you're gonna be finding. So in this problem, your z was negative 0.842 because that's what we solved. Your x is going to be, in this case, 100 because that's the z-score value we got. We don't know mu, and I gave you the standard deviation of 8. And again, we're going to use some algebra, and we're going to go ahead and solve this. So I'm going to multiply both sides by 8. And so I have 8 times negative 0.842. And I get negative 6.736 equals 100 minus mu, and then I'm going to subtract 100 on both sides and get negative 106.736 equals negative u. And how do you get rid of the negative? Is you divide or multiply by negative 1. So mu is 106.736. Okay, now again, since we did inverse norm, we do have to write a sentence. I'm gonna write it over here. So I'm just gonna say the average speed is 106.736 mph. Something really simple. And that's your sum. And that is the end of the first 2 sections of this chapter. Thank you.